All right, everyone, let's learn about the best way to make a good graph in a science classroom. So one of the first things you need to be able to do is to identify the variables in your experiment. So that means you have to identify what it is that the scientists changed. And the scientists changed the independent variable. Now, if you look at a data table, typically it's going to be the very first column. The second thing you need to be able to identify is the dependent variable. I always remember dependent starts with a D, and the dependent variable is the data that was collected during the experiment. It's typically the next columns. It could be 1, 2, or 3 columns after that first column, depending on the data that you are collecting. One acronym that you can use to remember the parts of a graph that need to be included is the word tails. You can see on the slide that T stands for title, A stands for the axes and including the correct units on the axes, I stands for intervals, L stands for the legend as well as maintaining your neatness and accuracy, and S stands for scales. So let's go through each of these. So let's start with the title. Your title needs to include both of your variables. It should include your independent variable and your dependent variable. So the first thing to ask yourself is, does your graph have an appropriate title that includes both of the variables within it? So the title should basically describe what it is that you're doing in the experiment. And so since we're including both of the variables, we're going to make a statement about what it is that we change and what it is that we collect data on. So if we look at this data table, we can see that we've got water depth, which is what we're changing as the scientist, and we're going to record at each of those different water depths the different temperatures. So we want to include both of those in the title. So you can see above the data table, I have a title that would be appropriate for my graph. It is going to be that I'm recording the temperature in Celsius. I include the units, and I'm comparing that to what are the different water depths that I have, and again, my units of in meters. The next step is to make sure that you label both of your axes, and we do want to make sure that we include the units and that we put each of the labels on the correct axis. So in a graph, the independent variable, which is what the scientist changed, is going to go on the x-axis, which is the horizontal side, the side that goes across the bottom. The dependent variable is going to be on the y-axis, which is going to be the side that goes up and down. And again, we don't want to forget our units. So here's a graph that has that same title from that data table on the previous slide, and we can see that on the y-axis we have our dependent variable, which is the temperature that was recorded, and on the x-axis we have what we changed. Every time we recorded a temperature, we were changing the depth that the water was at. Also notice that we've got units that are labeled for both of these axes as well. Next is the I, our intervals. We do want to make sure that we have equal intervals and that everything is clearly labeled. So when we are doing our intervals, we want to make sure that it always goes up by an equal amount. We could go up by 2s, going 2, 4, 6, 8. We could go up by 5s. We could go up by 3s. It just depends on what our scale needs to be, which we'll do that last, is determining what our scale is. Sometimes it's a little bit of a guessing game to figure it out, but in the last step, I'll show you how do we figure out what our intervals are going to be. The first step is going to be finding out what is the range. And the range is what's your lowest piece of data and what's your highest piece of data. So you've got to figure out how much does my scale need to go, because we don't always have to start at 0. So let's take a look at our data. We want to find that highest and lowest number for our independent variable. So if we look at water depth, the lowest number that we recorded water depth was 50, and the highest number was 200. So we can calculate a range there of about 150. Our dependent variable, the water temperatures, our lowest number is 4, and we go all the way up until 18, so we can calculate our range there. So our independent variable has a range of 150. Our dependent variable has a range of 14. So we're going to want to make sure that our scale is just going that amount. We don't necessarily have to start at 0. Noticing that our dependent variable is kind of lower numbers, we might start that one at 0. So the reason we figure out the range is to make sure that we're going to end up using all of our graph, or at least 75% of it. We don't want our graph to be just down in the little corner. We want to make sure that we're using all of our graph across the bottom because we went all the way across to a water depth of 200. And then we want to make sure that we're not just keeping all of our data in one little spot. We want to make sure it spans across at least 75% of our overall graph. So like I said on the previous slide, we have to find that range. We know that our independent variable goes from 0 to 200, but actually it really goes from 50 to 200. So we could go from 50 to 200 on that X scale instead of all the way at 0. We don't have to start at 0. The dependent variable started down at 4. So again, that one is going to go from, 4 is pretty close to 0, so we can start at 0 for that one and go 0 to 20. Once you've found your range, which we determined for our axes are 150 and a total of 14, you're going to have to figure out how many spaces you have on each side. So in the graph that I have in this video, on the x-axis I have 20 boxes, and on the y-axis I have 20 boxes. So since our range is 150, we're going to divide by those 20 boxes. And so if we take 150 and divide it by those 20 boxes, that's going to tell us how much we need to go up for each of our boxes. Now on this slide, I did do 200 divided by 20 boxes, just because you do get a nice even number. So sometimes you might want to kind of get that even number. The nice part about our range for our other axis is that, yeah, it's 14, but we're going to still use 75% of our graph if we go from 0 to 20 on that axis, and then we know that we can go up by 1 each. So it is a little bit of a figuring out game where we have to determine, okay, I want to make sure I use at least 75% of my graph, but I can kind of decide, am I going to start at 0? Am I going to start at my lowest data point? And what is going to give me the best number to go up by equal intervals? It's kind of hard to go up by 4s. It's much easier to go up by 5s. So sometimes you'll have to decide that. Going up by 3s is a little tricky, but sometimes that's just the best way to go. So because this is a PowerPoint, my numbers don't quite line up with the lines, but you can kind of get the idea of my equal intervals that I've determined. Along the x-axis, I did go ahead and start at 0, which that does make that I'm not going to use that first beginning bit of my x-axis, but I'm still using 75% of my graph, so it would be acceptable. My data actually on that x-axis doesn't start until 50. So I did do that just because it is much easier to go up by 20s. And then along the y-axis, my data is not going to start until 4, but again, it's only a very small portion of my graph that's not going to be used, and I go up by 2s all the way up until I hit that 20. The next part is the legend. We want to make sure that we're indicating what's being graphed with units and a legend. We want to make sure that everything is labeled, and we want to make sure that everything is indicated by different color lines if we've got multiple lines going on, or if we've got multiple bars on a graph, which is going to happen often in science. So on this graph, you can see that there's multiple lines that are labeled with different colors and different things that those lines are telling us. So that's just what a legend is. We just want to make sure that when we've got lots of lines or bars on a graph, we're making sure that the reader can understand what is in that graph. Finally, we've got the scale, and this ties right back to our intervals. We want to make sure that the majority of our graph is used and it's not tiny. So your graph should take up the entire page. We do want to have our highest number at each of the ends of our axes, and the lowest number doesn't always have to be 0. Sometimes we can start a graph later, especially if things like our data doesn't start until 1,000. We don't want to start our graph at 0 when our lowest data point is 1,000. So that's going to help you keep your scale to making sure that you use as much of the graph as you possibly can. All right, so finally finishing up, A lot of times, instead of just putting a little dot on a graph, it's very helpful to make an X at the point so that way you can use a ruler to connect all of those points a little bit better. And it's just easier to see than just little dots. You always want to make sure that you're following the lines to make sure your points are put in the right place. We want to make sure that our graph is neat and well done. So my suggestion is always using a pencil so that you can erase and fix mistakes. And then the number one mistake that a lot of students make is we mix up those variables and those axes. We want to make sure that that x-axis on the bottom is going to be our independent variable and the y-axis on the side is going to be our dependent variable.